Hey everyone, and welcome. Ever feel like math is a secret code? Well, today we're going to learn one of the coolest codes out there. It's called coordinate geometry. Think of it as a secret map that powers everything from your video games to the GPS on your phone. Let's jump right in. I mean, seriously, how does your phone know the exact route to your nanny's house? Or how does your character in a game know precisely where to jump? It's not magic, I promise. It's all thanks to this brilliant idea that helps us pinpoint the exact location of, well, anything. So to understand this secret language, we first need to build our map. And this map has a very fancy name. It's called the Cartesian plane. I know it sounds a little complicated, but trust me, it's actually super simple. Okay, just picture this. You take a normal number line that goes left and right. Now take another number line that goes straight up and down. And then you just make them cross right in the middle. That's it. That's our entire map, the Cartesian plane. Let's build it piece by piece. First up, we have our main horizontal road. This one is called the x-axis. It just goes from left to right, nice and flat. And now let's add our second main road, the y-axis. This one stands up tall, running vertically, and it crosses our x-axis to make a perfect plus sign. And that spot right in the middle where the two roads meet, that's our home base. It's the most important point on the whole map. We call it the origin, and its special address is always 0, 0. Every single journey we take on this map starts right here. So, we have our map now, but how do we actually find anything on it? Well, every single point on this map has a unique secret address, and that address is called its coordinates. This address always comes as a pair of numbers inside brackets, just like this, x, y. The first number x tells us how far to move left or right along our horizontal road, and the second number y tells us how far to move up or down. So the x coordinate tells you how far to go across, and the y coordinate tells you how high to climb. Here's an easy way to remember. You have to walk across the room before you can climb up the stairs, so x always comes before y. Finding a point is basically like a treasure hunt. Step 1, you always start at home base, the origin, 0, 0. Step 2, you look at the x number. If it's positive, you move right. If it's negative, you move left. And step 3, you look at the y number. Positive means you go up and negative means you go down. And boom! X marks the spot. Let's give it a try. To find point P with the address 4, 3, we start at the origin, move 4 steps to the right, and then 3 steps up. Got it? Now for point S at -2, 4. We start at the origin again, but this time we go 2 steps to the left because it's negative, and then 4 steps up. See, every single point has its very own unique spot on our map. Now, our two axes do something else pretty cool. They don't just help us find points, they also chop our map up into 4 different areas. I like to call them the 4 neighborhoods. The official name for these neighborhoods is quadrants. We number them with Roman numerals 1, 2, 3, 4, starting from the top right and moving around counterclockwise. And you know what? Each neighborhood has its own special rule. Check out this pattern. In the first quadrant, both the x and y numbers are positive. In the second, x is negative, but y is positive. Down in the third, both numbers are negative. And in the fourth, x is positive, but y is negative. This is an awesome shortcut. You can tell which neighborhood a point lives in just by looking at the plus or minus signs in its address. Okay, so we've got our map, our secret addresses, and our 4 neighborhoods. But why does any of this actually matter? Well, it turns out this simple system is the hidden engine behind a lot of the technology we use every single day. Here's a cool little math trick. If you have 3 different points, how do you know if they all line up perfectly? Well, you check if they're collinear. A really clever way to do this is to imagine the 3 points make a triangle. If the area of that triangle is 0, it means it's not really a triangle at all. It's just a flat line. And that shows you just how powerful this is. This map is exactly what makes GPS work. It's how animators make your favorite characters run and jump across the screen. And it's even how engineers design massive bridges and tall buildings so that they are safe. It is literally everywhere. That was a lot of info. So let's do a super fast recap of the most important things to remember. Ready? First, the Cartesian plane. That's our awesome grid map, the world where all our points live. Next, coordinates. That's the XY pair, the unique secret address for any point on our map. Don't forget the origin at 00. That's our home base, where every single journey begins. And finally, the quadrants, the 4 neighborhoods that our map is split into, each with its own rule about plus and minus sign. So at the end of the day, coordinate geometry is just a powerful tool that connects pictures and shapes with numbers. It turns geometry into algebra and algebra back into geometry. It's pretty amazing when you think about it. And that's a wrap, but here's a little challenge for you. Look around your room. If you pretend one corner of your room is the origin, what would be the coordinates of your bed or your study table? See, this secret map is hiding all around you. Thanks for joining me today.